and involves a fun little story that you get to read on your own here. But it mentions that Oksana and her classmates made a list of how they spend their time over a weekend. Now you need to recall that they're considering a weekend a 2-day period, and one thing to keep in mind here is that 2 days is 24 hours, because we may need to confront this information in the future. Anyway, you see this table here which lists all the activities and the average number of hours they spend doing each. Now, considering that it's a 48-hour period, we might conclude that adding all of these hour numbers together, it should add up to 48. So each one of these represents a certain fraction of the weekend, which is interesting because they give us these numbers as decimals. Okay? But we can't change that representation to fractions. You see here in number 1, they bring up a specific type of comparison. Okay? Several different types of comparisons. For example, one's a difference comparison to tell me how much more one thing has than another. Or, for example, a scale factor comparison, which tells me how many times bigger or smaller one thing is than another. In this case, if we read here, it says, in comparing time spent watching television to recreation time. Okay, and order matters here. It says, students spend more time doing which one of those activities than the other by a ratio of blank to blank. Now, first of all, we need to determine by looking at this table, okay, which one they spent more time doing, watching television or recreation time. And you're going to have to judge that on your own. But once you've determined that, when they ask you for the ratio of that one thing they did more of than the other, we need to write those numbers in that order. So let's say, for example, and you can use your finger here, but why don't you put your finger on sleeping? Okay? And let's say we wanted to write a ratio here of sleeping to eating. Okay, and of course we spend more time sleeping than we do eating, but if we were writing the ratio of sleeping to eating, and it's important we label our answers here, we might say the ratio was 18.4, and in hours we do need to label, and we can write this as a fraction or with a colon. Okay, we could even use the word to. But the ratio of sleeping to eating is 18.4 hours, okay, to 3.5 hours. Okay? Now, if we had switched this order around, the way we had stated the ratio, and we said the ratio of eating to sleeping, then we would simply switch these two numbers around. We would spend 3.5 hours eating to 18.4 hours sleeping. I'm looking for you to do the same type of thing with the scenario that they've given you and fill in these blanks. And I would like you to recopy this entire statement with the blanks filled in on your paper, not simply filling in the words on the paper. Okay? Now looking at number 2, here's what they've done. Instead of talking about a ratio comparison, they start to talk about a scale factor comparison. Now we can deduce this by reading it and noticing that it says the number of hours spent watching television is about blank times. Okay, we say times, multiply. Blank times the number of hours spent doing chores or homework. Now the interesting thing here is, if you notice, okay, the number of hours they spend watching television is 3.7 hours, and the number of hours they spend doing chores or homework is 4.7 hours. Now, the weird thing here is they're saying, well, we spend how much more time watching television, how many times greater amount of time watching television than doing chores or homework, when in reality, they spent less time. But we can still determine a scale factor here. So let's run this one, for example. What if we had a situation in which we said, oh, okay, well, how many times more, which is weird, how many times bigger is 5.2, okay, than 7.8? Okay. So what we're asking here is, what could we take 7.5 times to get 5.2? And of course we've seen things like this before in which we have to work backwards because this scale factor is not readily apparent.
7.8
So in order to turn this around and work backwards, let's do the opposite of multiply, which would be divide. Okay? So let's start here with the answer and turn it around and work backwards. Let's take 5.2 and divide by 7.8, and what this should yield is our scale factor. Now if you recall, division's great. Long division, not so bad. There's only one small issue here, and it's this. We can't have a decimal in the divisor. What we'll do is we'll turn this into a whole number simply by shifting the decimal to the end. And you notice we shifted it one spot to the right. What we do to the divisor, we also need to do to the dividend. This is much like dealing with a ratio. As a matter of fact, it simply is. So what this really is saying now is the answer to this quotient would be the same as if we took 52 and divided by 78. And now it starts to become apparent to us that 78 not only doesn't fit into 5, goes in 0 times, it doesn't even fit into 52. And this is where we start to see our decimal come about. Because now, bringing this decimal straight up, we know that the scale factor, after building in the 0, is going to be 0 point something, which makes sense now. What can I take a larger number of times to get a smaller number? And the answer to that is a decimal. So working through this one, we might say, well, 78 goes into 520. Maybe we say 6 times. And you know what? It wouldn't hurt to check. We say, okay, well, 8 times 6 would be, 48. 6 times 7 is 42. But we add this 4, and we get 46. Now, we see that this is 468. And I'm thinking here that we probably couldn't get away with squeezing another 78 on top of this, because what I liken this to is 80. It's really close to 80, and 80 would be too much here on top of this and go over 520. So what I notice is we put a 6 up here, and we already know 6 times 78 is 468. And now we can go ahead and carry out the operation of subtraction. Now, I do notice that I can't take away an 8 from a 0, so I have to borrow from the 2. It becomes a 1. We say, well, 10 minus 8 simply is 2. 1 minus 6, it can't be done without borrowing, so what we'll do is we'll borrow from this 5, which is nice, because this 4 minus 4 will be 0. But we say, okay, now this is 11. 11 minus 6 is 5. Now, here's the weird thing about it. If you haven't already noticed, this is 52 again. And when we build on another 0 here, we have 520 back. So we end up asking the same question again and again. How many times does 78 go into 52? And you know what? We're going to continue to get this 6, 6, 6, 6. So in this instance, if we said, okay, 7.8 is how many times bigger than 5.2, we'd say, well, we spent this many times more hours doing this activity than we did this. And this is something you're going to have to carry out on number 2. Now, lastly, I'm looking at number 3, and it says, well, in comparing time spent eating and sleeping, which they do list, to time spent in recreation and watching television, okay, it says what blank percent of the weekend was spent doing this, and blank percent of the weekend was spent doing this. The weird thing about this is we first have to express our percentages as ratios. Now, I know that percent means out of 100, and we can deal with that in a moment. But let's look at number 3. In reality, we say, okay, well, hold on. In the first situation, it says eating and sleeping to time spent in recreation, okay? Recreation and watching television. When we say eating and sleeping, you notice we have to put those two things together. We spent 18.4 hours sleeping, but 3.5 hours eating. So I say, well, total, we have a 9. You bring your decimal straight down. We say, this is 11, carry the 1. We spent 21.9 hours eating and sleeping. But of course, that's out of how many total hours on the weekend? Well, 48. So at first, we might say eating and sleeping, we spent 21.9 out of 48 hours doing this. Now, our task here is to actually convert this to a percentage. Now, what I know is percent means out of every 100. Of course, this isn't out of every 100. I tell you what, 48, as a matter of fact, is extremely close to the number is 50. If we turned this into 50, I could probably get away with saying this is approximately out of 50, okay, I maybe bring this up one. 22.9 out of 50 would be approximately the same as 21.9 out of 48. And doubling both of these, out of 100, about 45.8 hours. If it were out of 100. But we know that out of 100, this means approximately 45.8%. Now, we're not looking for an ish. This is one method to start to think about the reasonability of your answers. But I tell you what, in order to turn a fraction into a percentage at any time, what we'll do is we'll take that numerator and we'll divide it by the denominator, because that's what a fraction is asking us to do. So we say 21.9 divided by 48. What I'll ask you to do is, and this is okay because we have a decimal that's at the end of this divisor, is to determine how many times 48 goes into 21.9. Of course, we know it doesn't go into 2, nor does it go into 21, but it does head into 219. And I would suspect it probably heads in about 4 times. So use this as a guide to help you find this decimal. But once you find this decimal, it will tell you how many hundredths this fraction represents, and thus you'll have your percentage.